With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello. So question says this: among the following, the least third ionization energy is 4, right? So we have to tell the minimum third ionization energy. For it will be for manganese, it will be for cobalt or iron or nickel, right? So let's start solving this question, right? So we have first of all 4 elements, right? Or you can say 4 metal, that is manganese, right? So if I talk about manganese, right? So if I talk about manganese, so we have to find out the third ionization energy, right? So if it lose 1 electrons, right, so it becomes Mn positive, right? So and if it is lose another electron, so it becomes Mn2 positive, and if it lose another third electron, right, so it becomes Mn3 positive, right? Mn3 positive. That means from here to here, right, from here to here, it is first ionization energy, right? It is first ionization energy, and from here to here, it is from, you can say that from manganese plus to manganese, it is first ionization energy, but from here manganese to manganese 2 plus, right? So from manganese to manganese 2 plus, so it becomes second ionization energy, right? So from here to here, it becomes second ionization energy, right? So it becomes second ionization energy, and from manganese to manganese 3 plus, right? From manganese to manganese 3 plus, so it becomes third ionization energy, right? So in this state, right, so if I talk about the electronic configuration, as we know that half filled and full filled electronic configuration are more stable, right? So this, let's try to write its electronic configuration, right? So this is manganese, right? So the electronic configuration of this is will be 3d5 4s2, right? So the 3d5 4s2, right? And this is the electronic configuration, right? And if I, you can say if I lose 1 electron, right, so it becomes 3d5, it becomes 3d5 4s1, right? So it becomes 3d5 4s1, right? And another here, from here you can see that if I lose another 1 electron, so it becomes 3d5, right? So it becomes 3d5, right? So now this becomes half filled electronic configuration, right? In this Mn2 positive, it becomes half filled electronic configuration, and it is more stable, right? And so I can say that we have to supply a large amount of energy because it is very stable electronic configuration to eject this electron, right? So if I, you can say if I eject an electron, so the electronic configuration becomes 3d4, right? So I can say this is a, you can say this is a maximum energy, right? So we have to require a large amount of energy, right? In this case of magnesium, right? So this cannot be our answer, right? Because in the question we have asked that a list third ionization energy, right? So if I talk about, the cobalt one, right? So if I talk about the cobalt one, right? So similar case here, right? So if I lose 1 electron, so it becomes CO positive, right? And if I lose another electron, so it becomes CO2 positive, and if I lose another electron, so it becomes CO3 positive, right? So for CO to CO positive, so it is first ionization energy, right? And from CO to CO2 positive, it becomes second ionization energy, right? And from CO to CO3 positive, right? So from CO to CO3 positive, it becomes third ionization energy, right? So from here you can see this, the electronic configuration of cobalt is 3d7 4s2, right? So the electronic configuration of cobalt is 3d7 4s2, right? So I can write here, if I lose 1 electron, so it becomes 3d7 4s1, right? And if I lose 2 electron from the cobalt, so it becomes 3d7, right? So from it becomes 3d7, right? And we know that this 3d7 electronic configuration is not fully filled and not half filled, right? So it is more than half filled, right? So I can easily remove the electron, right? So it becomes 3d6, right? So it becomes 3d6, right? So now if I talk about the iron one, right? So if I talk about the iron, right? So similar case here. If I talk about the iron, so if I lose 1 electron, so it becomes Fe positive, right? So it becomes Fe positive, and if I lose another electron, so it becomes Fe2 positive, right? And similarly another electron lose, so it becomes Fe3 positive, right? So from here to here, right? So from iron to Fe positive, here this is first ionization energy, right? So from iron to Fe2 positive, it is second ionization energy, right? And from iron to iron 3 positive, from iron to iron 3 positive, right? So this is our third ionization energy, right? And you can see here the electronic configuration of iron is 3d6 4s2, right? So this is 3d6 4s2, right? So if I lose 1 electron, so it becomes 3d6 4s1, right? And from here if I lose 2 electron, so another 1 electron from here to here, right? So it becomes 3d6, right? So from it becomes 3d6, right? So now from here this is 3d6, right? So from if I lose one electron, so I am getting the stable configuration, that is 3d5, right? So that is 3d5. That means we have to supply a minimum amount of energy because we are gaining a stable electronic configuration here, that is 3d5, right? So this seems to be our answer, but because here you can see that we are gaining a stable electronic configuration, right? So now let's check our next answer, that is next element, that is nickel, right? So in the case of nickel, right? So if I talk about the nickel, right? Nickel. So nickel one, same here. If I lose one electron, so it becomes Ni positive, right? So it becomes Ni positive, right? And if I lose another electron, so Ni becomes Ni2 positive, right? So here if I lose another electron, so it becomes Ni3 positive, right? So it becomes Ni3 positive, right? So from here nickel to nickel plus, this is our first ionization energy. From nickel to nickel 2 plus, this is our second ionization energy, right? And from nickel to nickel 3 plus, right? So this is our, you can say this is our third ionization energy, right? So the electronic configuration of nickel, we know that it is 3d8 4s2, right? It is 3d8 4s2, right? So if I lose one electron, so I get 3d8 4s1, right? And if I lose another one electron, so it becomes 3d8, so it becomes 3d8, right? So because we have lose one electron, so it becomes 3d8, right? And now if I lose one more electron, so I will get 3d7, right? So this is not a half filled configuration and this is not the full filled configuration, right? So here we can say that this is no, in this case we are not getting, we are not, you can say we are not getting the minimum amount of energy. So that means in these molecules, or you can say in these elements, right? So the manganese, cobalt, iron and nickel, right? So in the elements, so the minimum amount of energy will be required for that, that means it is for Fe to Fe3 positive, because in this case, right? So in this case when we go from this series, so we are gaining a 3d5 electronic configuration, right? So 3d5 electronic configuration, and this is the, you can say that this is the stable electronic configuration, right? And because of this we have to supply, you can say we have to supply a minimum amount of energy. If I talking about the third ionization energy, right? So this becomes our answer, right? So I can say this will be the correct answer, right? So in the option you can see here the manganese, right? So the manganese will not be the right answer, right? As we have discussed here. And the cobalt will not be the right answer. So iron will be the right answer, right? So option C will be the right answer. And you can see here the D will not be the correct answer, right? So option C will be the right answer, iron, right? So that is Fe, because in this case in the Fe3 positive we are getting the most stable electronic configuration, that is 3d5, right? So hope this answered your question. So thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.